So we are going to discuss about real options in this video. So what happens generally when we do NPV analysis is the assumption is there is one project and there is one set of assumptions and there is only one choice. But in reality, what happens is obviously there are a lot of assumptions and there are a lot of choices available, and there are different points in time where the investments can be made, and we have the option to choose when to make these investments plus uh, which options to consider. For example, I could have an option to set up a factory which has a capacity of 1 million units. I have the option to set up a factory which a capacity of 1.5 million, 2 million, half a million, right? So which one do I consider? First thing. Second thing, given a choice, I would like to expand tomorrow or I'd like to reduce depending upon how the response is or how my product is behaving. So effectively speaking, I cannot have my NPV analysis to be restricted to just one option, because in reality that doesn't happen. So when I am doing my analysis, when I'm building my financial models to consider various cash flows, I have to bring in these options also into the model, into the consideration, into the decision making. So these options could be to expand, these options could be to increase the capacity, these options could be to add more products, right? So how do we do this analysis effectively? That is we are trying to look at these options using an analysis called real options. Okay, so as I said, generally our NPV is assuming that all the decisions are made at this point, and but you have a lot of options whether to start now or later, whether to expand now or later, whether to add one or more product, right? So how do we put these real options into our financial analysis? Basically using the small formula or an effective formula called project NPV. So what effectively we are doing, so I'm telling, let's say I have two options. One option is first option is okay to do as it is without considering any flexibility, without considering any options, right? So that means I have my NPV with an assumption that I'm building a factory with a capacity of 1 million units, right? So I have that NPV. Now what I'm also talking of is, what if I want to increase my capacity by another 1 million after some point in time? So I want to do that analysis also. So that means 1 million is today, 1 million units is today. After 1 year, I want to add one more 1 million capacity. So then what will happen? So what I will say is, what is the NPV that I am having without any option? Plus, if I expand it tomorrow, what is the cost of it and what is the benefit I'm going to get? So I'm going to combine these three, and I will arrive at a decision. So that is how this formula is also built: NPV without any option, NPV without any option, then what is the option cost, then what is the option value. So let us take one scenario. So in this scenario, what is happening? The company is building a new plant, and the NPV of the plant is projected to be so much if demand is high, and projected to be 3 million if demand is low. So here also we are considering two different scenarios. These are not two options, these are two different scenarios, because in reality there could be multiple scenarios, not necessarily that demand will always be the way in which we expect. So what we're telling, if my demand is good, my NPV is 8 million, and if my demand is not so good, my NPV is 3 million, negative 3 million. Okay, so this is one side. Then what they're telling, there is another option. The company has also secured a 1-year lease on some adjoining land with an option to buy, to expand the facility if demand is high, right? So what I'm doing is, I'm taking on lease some land today itself. I'll be paying the rent for next 1 year, so that I have an option to buy and expand the facility if my demand is high. If my demand is high, I will expand the facility. So that is your option. Your option is to expand the facility, right? So today, without expanding, your NPV is expected to be 8 million if your demand is high, and negative 3 million if demand is low. Obviously, only if your demand is good, you're going to expand. So they're giving the cost of the such lease and expected cash flows from the expansion as under. So option cost, that means if I have to buy this next land, then I have to pay lease rentals today for 1 year, which is 0.5 million. And if I expand, what will be my cash flows? Okay, from the time I expand, that is year 2 to year 6, for 5 years they are giving, so which is 0.4 million per year, annual net cash inflows and required rate of return. So let us see how to work this out. So first step is, okay, what they're telling, they're giving some high demand and low demand. So calculate the NPV without any option. So that is the first step of our formula. Calculate the NPV without any option. So what I'm doing here is they've given two equal scenarios. Okay, the demand will be high and demand will be low. The scenarios are equal, 0.5, 0.5. NPV is given, and expected NPV what I'm calculating, 8 into 0.5 and minus 3 into 0.5, which is 2.5 million. So this is based on the concept of expected value, which you would study in your quants in prerequisites probably. So 8 into 0.5 probability 4, and minus 0.3 minus 3 into 0.5 minus 1.5. So effectively 2.5 million is my NPV without considering any option. Now if I have to consider the option, what is the option cost? Option cost is 0.5 million, which they have given, and option will be exercised only if demand is high. Okay, so if I exercise the option, they're telling your cash flows will be year 2 to 6.4 million, so which I am putting on a timeline. So year 2 to 6, my cash flows, okay, 5 years cash flows, year 2, 3, 4, 5, and 6. So year 2 to 6, 5 years cash flows. What I do, what I need to do, I need to calculate the present value of these cash flows at this point in time, right? Because you're calculating the present, because here only you are expanding. You're expanding at the end of the first year, right? So you're expanding here. So what is the present value of these cash flows? Using your cash flow formula in your CFA calculator or any of the present value concept, you can arrive at this 1.6. But this is the number at this point in time. But we are trying to do the analysis today, which is year 0. So I'm discounting this 1.6 by 8%. So I am arriving at a present value of these cash flows today at 1.58. Okay. Now, option exercised only if demand is high. So this is the cash flow if I'm exercising the option. But what is the probability of exercising the option? 0.5. So I'm applying that 0.5 to 1.48, which is 0.74. Now I've got the option value. You've got the option cost, which you are going to incur today, and you have NPV without any option. So you are combining all these three, 2.5 minus 0.5 and plus 0.74, we are arriving at NPV of 2.74. Remember this 1.48, you have to multiply with the probability of exercising the option. The probability of exercising the option is 0.5, because only when demand is high, you will be exercising. So this is your real option. In reality, when we do financial models, we also consider the probability of adding these options, basically factoring in additional options, additional products, additional geographies. The model will be built in such way that if we want to add this at a later stage in time in the analysis period, we will do this also to consider the real options. So this is your real options. I hope it is clear. Thank you.